For our next session, I'm pleased to introduce Jussi, who is the founder and CEO of Hamina Wireless, to talk to us a little bit about hands-on with AI and Wi-Fi. So I'm going to hand that over to you.
Thank you so much. Thank you so much. Pleasure to be here. Thank you. Thank you everybody for joining. Much appreciate that. We'll quickly talk about, why it's so difficult to make really good Wi-Fi. Why are we seeing bad Wi-Fi? And how, a couple of tangible examples on how AI can help. All right. Thank you for joining the ride. My name is Jussi. They call me Jussi, the Wi-Fi janitor. I hope you enjoy the show. All right, so here's the good news. Wi-Fi almost always works. Wi-Fi standard is very resilient, and that's why at your home, Wi-Fi typically works absolutely fantastically. So if you deploy Wi-Fi at your home, even if you deploy it kind of badly, against the window, or just tape it to the ceiling or under the desk or whatever, or just leave it in the closet, it works to some extent, right? Even at your home, it can be bad, but home Wi-Fi is very easy, right? But at your, let's say, local airport or hotel or hospital or warehouse, Wi-Fi can be really bad, and it can be catastrophic if the Wi-Fi is bad. At your home, maybe the Teams cuts off, but if Wi-Fi fails at a warehouse, the warehouse pickers, whether humans or robots, they don't pick up the stuff from the shelves anymore. Your deliveries don't arrive. So it's a bit more critical. And like, this is an actual picture. I was at the Canary Islands just last week, and this is what I found in my hotel. So I was like, where I can see access points nearby, but I can't really see them physically. And turns out somebody had put them inside the false ceiling and mounted the wrong way as well. So that access point is greatly radiating to the ceiling of the next floor, or to the let's say the floor of the next floor, and to my floor ceiling. So that's a true story from 2 weeks ago. This is a bit earlier, like a year or two ago, from Heathrow Airport. There's an ancient, like 2005 Aruba access point behind the television. Of course, access radios and metal, they don't exactly match perfectly. So what is it, besides silly installations, what is it that makes enterprise Wi-Fi and larger than home Wi-Fi struggle? So in general, the challenge is the larger the Wi-Fi network, the worse it typically works. And couple of causes to that, like coverage holes, is obvious. You need a lot of radios, like in hotels, hospital campuses, university campuses. You need hundreds, probably thousands of radios. You need to figure out where to place them, how to configure them, this kind of stuff. Easily causes coverage holes, especially if you're on a tight budget. The other one is interference issues. Here's the good, bad news. Wi-Fi interferes, your Wi-Fi network interferes with itself. And especially with today's Wi-Fi, Wi-Fi 7, Wi-Fi 6, all of that kind of stuff, the Wi-Fi access points often are pre-configured from the box, especially home access points, to use what's called really wide channels, just so that you can see that big number on your speed test. But the wide channels also means a lot of interference when more and more Wi-Fi access points arrive the area, whether it's more of your access points, whether it's your neighbors, things like that. If you're optimizing for huge speed test results, you're optimizing typically for a terrible user experience, because you're also seeing the most amount of interference because of those wider channels. The other one is roaming problems. When your iPhone or laptop transitions from access point to access point as you walk around. Anybody ever experienced Teams calls, kind of struggling when you walk around your house or your office? That's roaming problem. So if the Wi-Fi is not well designed, not just for what's called primary coverage of the network, but also for secondary coverage. So you need two overlapping access points in most places of your office, warehouse, whatever, in order for the client device to smoothly transition from one access point to the next. It's a critical situation. If you don't want the call to drop, you need to design for that. And then, of course, we're seeing more and more Wi-Fi users, more and more capacity being drained. So if you do a sparse Wi-Fi design, or if you don't cover the critical high density locations well, where there's a lot of users, you will run out of capacity. The radios will be overloaded, and especially Wi-Fi runs out of what's called airtime. Everybody's sharing the same Wi-Fi frequencies. So if you don't design it well, you'll run out of capacity as well. So how do we make a really, really good Wi-Fi design? We simply put, we really take the building characteristics into account. So the walls and the elevators and the doors and things of that nature. And then we find ideal access point placement, so to maximize the coverage, maximize the interference, ensure capacity, and minimize cost. And then we appropriately configure and tune the network. Finally, we hopefully also validate the network on site. So we go on site and we make sure doing walk testing that the entire network works. All right. So this was the day in the life of a Wi-Fi engineer, still in 2024. Remember, we're talking about AI today and AI, how AI can help. And AI did not really help a Wi-Fi engineer in his Wi-Fi design before 2024, not really at all. So let's take a look at a couple of years ago. How did the Wi-Fi engineer do a design? You had to find some kind of floor plans of the facility, set kind of the metric or feet scale to the floor plan so that we understand how much is 10 meters or how much is 35 feet on the floor plan in order to understand the coverage areas of the Wi-Fi access points. Then you had to define or kind of use a computer program to manually draw all the boundaries on the floor plan. And this took hours and days. So you had to draw walls of the area on top of the floor plan, and elevators and doors and shelves in warehouses and retail, and staircases and all of that kind of stuff, and define the materials for each. And only then maybe could you start designing Wi-Fi. This is hours and days later. Like most of the Wi-Fi engineers' time went to these kind of non-Wi-Fi related tasks. That doesn't make any sense. But then they could start designing Wi-Fi and kind of the switching and cabling to match. Well, how can AI help here? Let's take a quick look. Side note, it's time for an advertisement. If you want to contact me, if you want to see my posts on, better Wi-Fi, new Wi-Fi things, new private 5G things, things like that, hit me up on LinkedIn. Just Google Jussi Wi-Fi or hit me up via email. 5 seconds to take a screenshot. 4, 3, 2, 1. And we're proceeding from the ad break. All right, so let's take a look at some kind of a Wi-Fi design. So I went online and downloaded. I just put in on Google Images residence in floor plan. All right. So this is what I found. Since I'm a Marriott guy, let's go with a residence in. Let's say we need to design a network for Residence Inn by Marriott, and all we have is this advertisement grade, terrible quality floor plan of the building. So this is probably some kind of an advertisement floor plan or taken from somewhere. I don't even know, but it has nice logos and everything. But using this floor plan, in let's say 5 minutes, we would need to design decent quality Wi-Fi for this hotel. How would we go about doing that? Again, remember those manual steps that we had to previously go through. Well, luckily things have progressed. Let's see what AI can do for us. So here's the downloaded floor plan. I'm just going to take that and drop that on my web browser canvas, okay? I hope you can still see it. I'm just maximizing my web browser. And now, as AI is working, it's automatically doing a few things. See what happened here. AI automatically understood what is the distance of 50 feet on the floor plan. So if we now want to use the scale tool to measure any distance, we can. So we now understand for Wi-Fi design, how much is 62 feet and what distance is this? It's essential for estimating the coverage of the Wi-Fi. Okay, that's great. We understand the scale and AI did that for us. What else did AI do? For Wi-Fi design, it's kind of nice to understand what areas should I cover, typically inside of the building, and what areas not. Well, AI also did that for us. So that helps in kind of understanding like the system will not show even coverage outside the building. So your reports of the Wi-Fi design will look great. The heat maps will not show outside the building, things of that nature. So AI did that for us too. We call that a scope, like what's in scope, what's out of scope. You can of course manually edit that as well. For example, if you want to exclude the elevators from the design, we could do that too. Let's just do that for the fun of it. I'll just exclude them. I'll exclude them. There we go. The elevators are now excluded as well. So outdoor areas excluded by AI, and I manually excluded the elevators and did a terribly sloppy job at it. What else did AI do now? Okay, let's take a look. AI actually also gave us the walls, the elevators, the doors, everything. And this is the holy grail, right? Uh, when we understand the walls of the building and the elevators and things like that, with this, we can then start to estimate what is the true coverage of, let's say, a Juniper AP45, which, by the way, radiates Wi-Fi into different directions like this. So, or the brand new AP47 from Juniper, which is a more directional towards down than the AP45. Either way, let's take AP47 since that's newer. Now, look at how the Wi-Fi does not really penetrate the elevator, but it goes nicely through the corridors. It also goes through the drywall between the rooms quite nicely, but not nearly as much as in the corridor. And if we move the access point to the room, you can see how the walls make quite an impact here, but not as drastic of an impact as the elevator. Remember, we scoped out the elevator, so we don't even show signal there. If we want to bring the elevators back and see how the signal is in the elevator, we can certainly do that too. All right, so see how much AI helped us here. It did the scale, what's in scope, it did the walls, the doors, the elevators. Could we now use this AI info to also AI data to also make a decent design out of this network? Okay, let's ask the system. Typically, these kind of hotels would be done access point in every room or access point in every other room or kind of a mixture, sometimes every room, sometimes every other. Sometimes you see, I was just again in South Europe and I saw a design like this in my hotel. Some of the access points were in rooms, but most of them were in the hallway. And see what happens when you place the access points in the hallways. They don't really reach the rooms. So the Wi-Fi might work great in the hallways, but like here, Wi-Fi works great in the hallway, but it doesn't penetrate the walls to get to the rooms almost at all. That's not great, is it? Let's ask the system how the system would like suggest us something to start designing the network to. That's not bad at all. So, like I said, typically hotels are one access point every room or one access point every other room. And check this out. Let me just hide the heat map so it's easier to see. That's not a bad design at all. And then we can, of course, manually modify the design. Let's say I want one in the hallway and I want one there when people get out of the elevator. Maybe move that access point there. But that's actually a decent starting point for us. Okay. So AI helped us also, since it helped us understand the building characteristics, it helped us make a pretty darn good design, okay? And then we can ask like, okay, well, do we have enough of what did I say? I mentioned coverage. Do we have good coverage? We do have good what's called primary coverage. So the best serving access point works great. Second serving access point works great, except in elevators and in some toilets, things like that. Not overly concerned about that. It's looking great even for the second serving access point on all Wi-Fi 6 and 7 on 6 gigahertz, Wi-Fi and 5 gigahertz and 2.4. 6 gigahertz is only available in Wi-Fi 6E and Wi-Fi 7. And the system even minimized, remember how your Wi-Fi can interfere with itself. The system even minimized the interference. There's absolutely no interference here. It optimized the channels of the radios automatically, see how they are all on their own channels, and when the access points would start interfering with each other, some of the radios were disabled that would hurt the system more than help. That's pretty good. That's pretty good. I'm kind of liking this design. Good coverage, excellent secondary coverage as well. No interference. Okay. And what about that roaming? Remember, we talked about how does the client device roam from one access point to the next? How would a brand new iPhone work when the high-end customer comes to Residence Inn? That probably never happens. It's full of startup slobs like myself. When the customer comes to Residence Inn, how is it going to work? We show the experience of the customer and the experience of the brand new iPhone, or if it's an Android phone, it behaves differently. If it's an iPad, it behaves differently. We show the experience of that device day in the life of a customer of the hotel. Okay, that seems to be working pretty good. So some might say AI is full of fluff and it's all still marketing hype when it comes to networking and AI. I tend to disagree. All right. So you could say that's an easy design. That's only a hotel. So what about something bigger? Let's do something bigger. How about that? We'll do a fresh start and we'll take a look at, I don't know, a data center. Yeah, or warehouse. Let's do a warehouse. So warehouse is slightly more complex, and also they involve things that hotels don't. Things like shelves and directional antennas, things like that. Can AI help there as well? So before this meeting started, I went to a site that has beverage warehouse floor plans. Yeah, you can find a lot of floor plans out there on the interweb. So let's just save this beverage warehouse floor plan, and I will drop it in the canvas as well. Bam. All right. So there's the beverage warehouse floor plan, but did I set it as a warehouse? I sure did. So now the AI is processing it again. And the first thing I forgot to say that the AI actually looks is this a floor plan at all? So AI can also determine that, and it's really good at that. And that's kind of a classical AI problem, if you will. It first determines for example, if you put a picture of a cat into the system, it will say, our AI will say, no, that's a picture of a cat. That's not a floor plan. Let's not even try to process it. Okay. And now AI has processed it has found it is a floor plan. These are the usable areas. This is the scale of the floor plan. But it also found all of the shelves from this. Again, these are not CAD files or anything like that. This is simple JPEG images. This can be an image taken from, I often take pictures of the fire escape plans of the hotels and use those. This was a simple image, two-dimensional normal picture taken from the internet. And AI automatically built a full warehouse three-dimensional model for us to do the wireless network design. And with this, we can use things like directional antennas, whatever we want to make an optimal design for this network. Let's say we want to use a battle axe type of a antenna in here to make a beautiful design for this warehouse. We will put it on the ceiling of the warehouse at 14 feet. and we will look at coverage. And here we can see, indeed, then we can start aligning the antennas and moving the radios. Maybe we align it ideally so that this guy blasts along the hallway, and then we put the next one between the shelf, align it appropriately, and see how nicely that blasts throughout the warehouse as well. So that's kind of how you would design a warehouse. But the thing is, with the warehouses, it's not computer aided in terms of the placement of the radios, alignment of the antennas, things like that. Wi-Fi engineer, nothing beats a Wi-Fi engineer when it comes to at all more complex design, and the automatic planning systems, they always need to be validated as well. Okay. So we can do warehouses, data centers, all of that kind of stuff. That's kind of neat. Let's go finally back to our original plan. We talked about what if we also wanted to do cable planning. Let's put a switch in this hotel floor plan, and we know that there is already an existing switch to connect all the access points to, and the switch also feeds power, obviously, to the access points. So let's place that in the networking closet, and it's a failure. So clearly this switch, actually, the old switch that was maybe powering the old Wi-Fi network, runs both out of ports as well as out of power. So we will just upgrade the switch. No more exclamation mark, no more red switch. That's amazing. That's great. And now let's also do cabling. So we can see cables are now pulled for each of the access points, but are we really going to pull the cables through the walls? Probably not. Let's just do cable trays here. I'm gonna say in this hotel, the cable trays actually, or the conduits where the cables go from one place to the next, they actually go along the hallways. That's a pretty typical setup in a hotel. So we're gonna put draw 2 cable trays on the hallways and see how beautifully now the cables are routed first to the tray from the access point and only then to the switch. Then we're pretty much done. We just ask the tool, give me a bill of materials. Okay, we're gonna need 28 access points of this type, all of them mounted to the ceiling. We're gonna need 1 switch, 48 ports, 1024 watt output, and this much copper cable for it as well. That's pretty good. Now I can just create a report of the simulation and fire this off to my customer. Maybe I would add a logo, maybe I would customize the report, but the beauty is you can actually go and see my report as well. Why not? I'll just leave the bill of materials, and maybe I'll leave the access point placement and coverage and a couple of other views so you can check them out. I'll take out Bluetooth and Zigbee and all of that kind of stuff, because that's what we do not need at all. And we are ready to rumble. What I'll do is I'll put, I don't know if you guys can actually see the chat here. It may be disabled, but if you do, that's great. Can the attendees, can Jeff or somebody help me? Can the attendees see the chat at all? Okay. Then I will not share that. All I will say is what your customers will get. You can create a PDF document out of it. But what's nice is your customers can also take the link that you send them and dive right into the project that you made. So this is your customer's view. You can annotate all you want and stuff like that, but your customer on their web browser can go into the simulation, enjoy it, see the coverage of the radios, see everything, see the client, even the client view of the system, so they can even walk the client around and see how it works. That's pretty snifty. That's all I have. I hope you had a great you've had a great RCR event so far. And if you want to find me, just go on LinkedIn. You can find me here.
Perfect. Thank you, Jussi. So we do have about 4 minutes left, 3 or 4 minutes left, and we have a few questions here, mostly clarifying questions about things like how does the program know the ceiling and shelf heights? So maybe you can
That's
talk to us
that's
about
an
that.
excellent question. That's an excellent question. So the ceiling height depends on kind of what kind of map it is. So if it's a hotel, it's your typical indoor carpeted space. But for example, in the warehouse, the ceiling is much higher, and the shelves have a default height that is below the ceiling level, but still fairly high. If it's a retail floor plan, then the shelves are lower than warehouse, the ceiling is lower than warehouse. Excellent question. Thank you.
Yeah, great. And then another clarifying question. Can you talk to us about like how you know whether the material in the walls is RF transparent or not?
That's an excellent question as well. In the tool, all the wall materials, everything is completely customizable. So you can just simply paint an area that you know is an X-ray area in a hospital, and then switch that material from, let's say, heavy drywall into concrete and stuff like that. So you can customize everything you need in terms of wall material type and attenuation and things of that nature.
Okay,
Great
perfect.
question.
Yeah, Yusi, thank you so much. And thank you everyone for tuning in.
Thank
See you
you.
at the next sessions.
Thanks so much, guys. Thanks for having me.
Thank you.